Hello everybody and welcome to Unit 2 of AP Chemistry. In this unit we will be studying Chapter 4, which will cover aqueous reactions and solution stoichiometry. To start off, let's talk about the properties of water. Water has an extremely high melting and boiling point. It also will expand when it freezes. This is because of the interactions between independent water molecules. And we'll talk more about this when we get to chapter 13, I believe, where we'll talk about intermolecular forces. So right now we're just going to understand that water has high melting point, boiling point, and will expand. Water is also a very great dissolving agent. It will dissolve a variety of substances very easily. And what's also interesting about water is pure water is very rare to find in nature. The water that we come in contact every day, like our tap water or our drinking fountain water, has other ions or minerals in it. So when you go to the tap at home and you take a glass of water, there's chlorine and fluorine and all of those ions put in to make the water better for us to drink. But pure water is very, very difficult to come by. Before we go any further, let's talk about aqueous solutions. What are they? What make them up? An aqueous solution is a solution where water is the solvent. So water will be the dissolving agent in an aqueous solution. Let's review what a solution is. Remember that a solution is a homogeneous mixture made up of two or more substances. And in a homogeneous mixture, you cannot tell the two components apart. Heterogeneous, you can see the individual parts. In a solution, you can't. So think of salt water. You cannot see the individual salt molecules in a saltwater solution. The solution is made up of two components. You're going to have one found in greater quantity, and that's your solvent, and that's what's doing the dissolving. And then you have what's being dissolved, which is called the solute. So if you were looking at a saltwater solution, your water would be your solvent, and your salt would be your solute, because the salt is what is actually dissolving. What's important for us to also understand is the properties of aqueous solutions. And one of those type of properties is called an electrolytic property. What is an electrolyte? Well, first of all, an electrolyte is a substance whose aqueous solution will form ions. So when you dissolve something in water, form an aqueous solution, the compound actually breaks apart into ions. And because these ions are present, you're able to conduct electricity. Most of the time, you may have a few molecular compounds that are able to do this, but all ionic compounds are electrolytes. Non-electrolytes are substances that will not form ions in an aqueous solution. That way, that also means that you will not conduct electricity through a non-electrolytic solution. Molecular compounds like sugar will not break up into ions. So when you dissolve sugar into water, the sugar stays intact. The sugar molecule, if we could look down at the actual individual molecules, are still intact. So the only thing you really get out of sugar water is a sweet taste. No electrical current can go through a sugar water sample. When ionic compounds dissolve in water, what happens is that you will have a dissociation of the ions that make up that compound. Dissociation and ionization are the same thing. It means that the ions will break apart. So you dissociate into ions when ionic compounds dissolve into water. Molecular compounds, however, when they dissolve into water, they keep their structure. Their structure stays intact and it's maintained. There are some molecular solutes that interact so strongly with water that they will form ions, and these molecular solutes will be electrolytes, and they usually are in forms of acids and ammonia. The strong acids are definitely electrolytes. They will dissociate completely. The weak acids will dissociate, but just a little. And we'll talk about the difference between the two here in a second. So strong electrolytes. Strong electrolytes exist in solution completely or almost completely as ions. So when the ionic compound dissociates and dissolves, you will have the majority of the solution as ions, if not all. Sometimes it completely dissolves. So all ionic compounds and a few molecular compounds can do this. An example of a molecular compound that can do this is hydrochloric acid. Hydrochloric acid, when it dissociates, breaks into hydrogen and chlorine ions. You also have an ionic compound example here. You have sodium chloride. When sodium chloride dissolves into water, it breaks up into sodium ions and chlorine ions. It's important to note the AQ in parentheses. When you see that AQ in parentheses, that means that you are dealing with a water-based solution. You are dealing with an aqueous solution. So that thing is actually dissolved into water. When we write these strong electrolytes in dissociation form, which is what you see here, these two examples are examples of the compounds dissociating. We do use an arrow just like a regular equation. What's important to note here with strong electrolytes is what direction the arrow is pointing. If you look at both of these, the arrow is pointing in one direction, and that direction is towards the ions. What that should indicate to you when you see an equation written like this is that when it dissolves in water, these compounds will completely dissociate into their ions. You will no longer have any molecular HCl in solution, and you will no longer have any ionic compounds of NaCl in solution. So when they dissolve, they go 100% into ions. Weak electrolytes are the molecular compounds that will dissolve a little bit. These are our exceptions. Most molecular compounds will not produce any ions, and those are the non-electrolytes. But we have a few molecular compounds that will dissolve a little bit and dissociate into a very small concentration of ions when they dissolve into water. So acetic acid is an example, and if you don't know, acetic acid is a weak acid, and it will ionize or dissociate very, very slightly when you dissolve it into water. But that dissociation is what makes it an acid. So when acetic acid dissociates, it will dissociate into hydrogen ions and acetate ions. But it will only dissociate ever so slightly. So in an acetic acid solution, you will actually have hydrogen ions present, acetate ions present, and you will still have the molecular compound of acetic acid. The HC2H3O2, the reactant side, will still be present in solution. So you can notice, if you'll look, that the arrow here in the center is double-headed. So it goes in both directions. That's because some ions, or some of the acetic acid will dissociate into ions. In the meantime, there's some ions that will reconnect and form the acetic acid molecule again. So all three of those are present in solution. And these are weak electrolytes. What we're going to do now is I am going to stop this recording, and we are going to move on to predicting solubility. This will be the next video that you're required to watch, and we're going to talk about how to know whether or not a product will be in aqueous form or solid form when they're mixed in reaction.